Everybody, today I want to talk about state tables inside of CCT. What are they? What are they there for? What can we do with them? Let's begin. So state tables are a way to do if then else programming inside of CCT. It's basically a way to do script programming like an if then else statement inside of CCT. And those it's where incoming states are prioritized. They start at the top and then work their way down. An output controller action is defined by each state. So our states are over on the left and our actions are on the right. We'll get into that here in a second. And state generators and modules from the other columns become individual tables. See how that goes. So here is a picture of a state table. Remember, states are over here on the left-hand side, columns are over here on the right, and the state is telling the column what to do. The state is telling what the program what to do, what state to be in the program. So if we look here, water system flush pass-through is the highest priority, but technically it's the highest priority of the cooling valve control. Everything else is a star. A star just means uh, next line. That's all a star means. So if we're in false mode, it just goes to the next line. See, there's stars everywhere. If water system flush pass through is true, everything else drops down to the next line except for water flush right here, the proportional valve cooling control. That would stay in water flush. That would hold that. That would be the highest priority that can go. It would not drop down to the next line because the line is water flush. The next line down from there is low temp alarm. And again, low temp alarm would cause the cooling mode to go into water flush. We can assume that water flush is 100%. We can go look at the program and see, but actually I believe there's a point on there where we can make water flush whatever we want it to. It comes default at 100%, but we're telling it the state to go into that whatever we're telling it to do 100%. Next thing down is smoke control sequencing. You see this actually controls an outdoor air damper and the valve. Now notice the low temp alarm up here did not close the outdoor air damper. It remained a star no matter what it was. So when the low temp was in alarm, it actually left the outdoor air damper at whatever it was. Now, if this is a hardware shutdown, if your low temp alarm was a hardware shutdown, it would shut down the unit, right? But we would have to assume that the low temp alarm was on a hardware shutdown to shut down that unit and close out outdoor air damper. If not, the program would keep trucking along and it would just open up the cool water valve and not do anything with the damper or the fan or the heating valve or anything else. Let's see. In this instance, why is the chill water valve open and the damper shut? Well, let's see. Right here, our low temp alarm is in water flush mode, and our smoke control sequencing down here went to pre-shutdown, which will be hold. So let's look at CCT. And I have an air handler program here. Doesn't really matter what controller we put it on. It's probably artificial right now. No, it's the 9090. Probably needs some extra points here, but we're not really concerned about that. What we want to look at is the state tables down here. So the state tables live on this lower half of the screen. You got parameters, connections, state tables. And if we just double click this blue line right here, we just make this the whole thing. And as I said, you got the priority works from the top to the bottom. So if a star means I don't care, move down to the next line. again, water system flush through here would have control over cooling, preheat, and reheat valves. That would throw those all into there. Same thing with low temp alarm. That would affect those three valves again. Fire damper alarm in the disable mode, we do a lot more here. We make sure our humidifier is off. We close our damper. Um, we go low outdoor air temperature. And our supply fan, we actually go emergency off. So that would lock out our fan, our valves, close our damper, and turn off the humidifier. Sorry. Smoke control is the next one down. That would do a lot of things. Now, the state tables, if you don't understand it and can't build one, no problem. That is where you want to go for troubleshooting purposes. If I throw this thing in simulate, that would be the same as if we were commissioning a live system. It would actually show what state these things need to be in, what our states our outputs are going to be in. And it highlights it green for you. So we can look at here and we can figure out what is going on. Why hasn't our damper open? Well, our damper hasn't opened yet because we're in ramp F. So supply fan ramp. Oh, we just went into fan fault, and that puts our fan at minimum, and it doesn't affect anything else. So let's see. We have to go up a little bit because we are in self-result fault that is affecting our humidifier, our damper, and our valves here. And right here, we see that our reheat is off because our mixed air is satisfied. So it'll highlight everywhere for you to troubleshooting purposes. So that's why our damper is closed, because we're in this self-reset fault. And I'm assuming it's because we didn't get a status over here of a fan. If we were to throw a fan status at it, command on, it said self-setting, so let's see if it resets itself. If not, oh, it did. So we went back normal up there. So now we're back at ramp supply fan. So supply fan is ramping up. You see here, we're in ramp mode. And we're giving it some speed. If we threw some duct static at it, we would eventually, we're at stabilized system, so we're still off right here. And you can change these values here. You change how the programs will react to the states to match the sequence. So if the customer states or the engineer states, hey, during ramp up mode and stabilized system mode, I do want that proportional outdoor air damper open to minimum. We would change these closed to ramp minimum outside air. Ramp minimum outside air should have our damper open. 10%, see? So we're open. Humidity, we're controlling humidity now. So we must have released the humidity right here, normal humidity control. Ramp minimum outside air on the damper, and all valves are off. Seems that we're probably satisfied there. Yep, satisfied. So that's how you can look at it as a troubleshooting scenario. you can't do anything in commission mode or simulate mode, but inside of configure mode, if you wanted to create your own state table or add to it, you come up here and hit edit. Over here in the yellow, right underneath state table, you can create a table, which remember is on the left-hand side. It's telling the controls what to do, or you can create a column. That would be the right-hand side. That would be the actual controls, getting told what to do by the state tables. If you do a side loop, you got this box right here, create state table selection, interlock the side loop. If you choose any one of these side loops, say you're doing an analog binary control, maybe you're turning on a exhaust fan based on temperature, and you're going to throw in a temperature sensor, and you're going to turn it on when it gets 80 degrees. Do this. Control. That's going to create our output right here. It also, over here on the left side, it created a column for us. Now we do have to tell it when we want this thing to go in control. And maybe we want it to go into control all the time. If that was the case, we probably don't want it here unless there's times where we don't want the exhaust fan to work. And maybe that's during a fire damper thing. So if we're on fire damper, we want that guy to go off, but anything else we want it to go in control. And this would actually control our exhaust fan, you know, or maybe we want it down here in smoke control sequence, you know, if we were doing shutdown or pre-shutdown, we could tell it to go off, but if we were in normal, we could tell it to go on. So we could start there. There, we can have it off here. We can have it off there and off there, and only have this guy go into control on. Pressurize would be off. Depressurize, maybe we actually want it on or depressurize. And a purge, we'd want off, right? So this would actually kick the fan on for us. We can do that. So this is playing with the state tables right here, matching it how we want the exhaust fan to run. Now remember, it is priority based, so as soon as it hits the fire alarm damper, we want it off. Maybe we don't care about it when this is enabled, so that's when we start it, and this is where we want it to go and control at. That's how you would do that. You would hit apply and be done. If we wanted to create an actual state over here, say we wanted to do something off of supply fan status, we can come over here and hit it, right click, create a new state table. We'll do SF-S. Well, we think it's a low priority thing, so we're going to put it at the bottom of the list. Now we got to choose the correct enumerations. That is an off on, so that's okay. We're good. And then we'll say we want that exhaust fan running anytime the supply fan running if we've have everything else down here. So this will have to be not in control. There we go. So that would have to be normal for us to make this work. But on, we would go into control here. Hit apply. Now this is orange because this is a state that hasn't been connected yet. We haven't made any connections. If we wanted to make some connections, I'd go to my connections tab, come here to status, make a connection, state table. This is that state, the table that we just made. Now when I go back into it at the bottom, you see this is yellow. So there we go. We added a state. Before we kind of added a column by going through the side loop. There's our column, there's our state. So hopefully you learned a little bit more about state tables. Um,